So, what is waiting for you this afternoon? After a short introduction and welcome, we'll look into project presentation and see how the Net Zero Industry Act takes place in reality, so to say. Then we'll have a short coffee break. We will look at two more projects, and then we'll have the breakout rooms with the Q&A sessions. And then we'll wrap up the afternoon. So what happened so far and where are these projects coming from? The first joint call took place in 2022. The second joint call closed in November 2023, and the projects will start at the end of 2024. And the third joint call opened on 19th of September 2024. And the deadline for pre-proposal submission is the 21st of November 2024. And next year we'll have the fourth joint call. Next, I'll give you some numbers so to have a better understanding of the sheer volume of what we are doing. So for the joint call 2022, we had 112 pre-proposals, 65 full proposals, and 46 funded projects. This means 530 project partners from 28 countries and over 86 millions of euros funding and 46 national funding organization taking part. So these are really huge numbers and very impressive. And now, next slide, please. We'll look at some of these projects and what they are doing and how they are picking up the topics that we discussed this morning. So the first one presenting will be Dylan from CO2RR, and I would like to ask him on stage and give the stage to him for his presentation. Hi, Dylan.
Hello. Thanks very much for having me. Hi, everybody. My name is Dylan Marks from Airfix, and I'm very happy today to introduce you to the Carbon Rhine Route project, or CO2RR. This is a project focused on carbon dioxide removal, or CDR, and carbon capture and storage, CCS, across Europe. Next slide, please. Now, to start with, why Carbon Rhine Route? And the name represents our mission, and that's CO2 transport and CO2 removal through the Rhine Valley, from Switzerland through France, Germany, and others, all the way to Northern Europe. It's an important transport corridor today in Europe, but also, as we see it, a key carbon management route. What we aim to do is establish the first commercial, international, and multimodal CO2 transport value chain in Europe. Now, maybe to briefly unpack each of these terms. Commercial, because we have to create scalable and bankable business models to make CDR and CCS projects viable. It's international because we have to connect inland emitters to storage sites, which currently are mostly offshore in the North Sea. Multimodal because we need a range of transport modes to connect sources to sinks, such as trucks, trains, inland barges, and ships, possibly with pipelines becoming available in the future. And then value chain, because we need to develop and coordinate every step from capture to transport to storage in a single integrated process. Now, the Carbon Rhine Route Consortium are industry players that together cover the whole value chain. The project is coordinated by Airfix, a Swiss company dedicated entirely to supporting the development of biogenic carbon removal projects in Europe. On the capture side of things, we have Carbon Impact, our French partner, Carbon Impact is a carbon removal developer supporting biogenic CO2 emitters in France and in Switzerland in developing CCS projects. Chemoil Logistics provides the transport backbone of the project. Chemoil is the largest Swiss rail logistics company and are dedicated to transport so-called dangerous goods across Europe. And finally, we have Northern Lights based in Norway. They are an offshore geological storage provider in the North Sea and a key player in both the CDR and CCS landscape. Now, Northern Lights joins our consortium as a self-funded partner, but we are working very closely with them. Next slide, please. Now, the project's focus is to develop a European transport and storage network for CO2, so demonstrating its feasibility and its viability. Some key innovations of our projects include focusing on biogenic CO2 emissions. So that covers emitters such as waste-to-energy plants, biogas facilities, and wastewater treatment sites. And so this is CO2 that originally comes from biomass. And the distinction is important because the process of capturing and permanently storing biogenic CO2, as opposed to fossil CO2, results in a carbon removal or negative emission, as opposed to an emission reduction with conventional CCS. Small and medium-sized emitters are at the heart of our projects. They typically lack access to large-scale CCS, and we're trying to build an inclusive network. We're exploring a clustering approach for emitters, whereby emitters in the same region can combine their CO2 in order to share infrastructure to unlock more and more efficient transport modes and reduce costs to increase efficiency. Then the multimodal transport aspect of the project is essential to connect these inland emitters with storage sites in the North Sea in the absence of widespread pipelines. Finally, there is a focus on developing business and risk-sharing models that will distribute the costs, the risks, and the benefits among the different players in the value chain. So that's the emitters, the transport providers, and the storage operators to make CDR and CCS more accessible for smaller players. Next slide, please. So our main goal at the Carbon Rhine routes is to facilitate the capture, transport, and storage of 1 million tons of CO2 by 2030. By 2026 already, we aim to provide a commercial, scalable blueprint for inland carbon removal. And that is when our first emitter will transport and store its own CO2 in 2026. But the project also contributes to the wider climate transition by accelerating the deployment of CDR and CCS projects and generating negative emissions, which are a key part of the climate change mitigation puzzle. Then by supporting smaller emitters in that process, which individually have limited emissions, but together can meaningfully contribute to wider decarbonization efforts. And finally, by creating this model, this blueprint that others can replicate to achieve Europe's climate goals. Next slide, please. Now, CCS is one of the 8 strategic net zero technologies listed in the Net Zero Industry Act. However, CDR is not explicitly listed. But here I want to talk about how the Net Zero Industry Act is interwoven with our own projects. So the first 3 points on this slide relate to our project's alignment with the Act's goals, and the last 2 rather how the Act can support our projects. So to start with, the Carbon Rhine route project directly contributes to the EU's decarbonization targets of capturing I think it's 550 million tons of CO2 every year by 2050. But it also contributes to the Net Zero Industry Act's targets for an annual injection capacity of 50 million tons of CO2 per year by 2030. Secondly, by developing multimodal CO2 transport networks, we're creating an accessible and scalable solutions for small and medium-sized emitters, which aligns with the Act's push to make CCS more commercially viable across Europe. CO2RR will hopefully also reduce the cost of CCS by optimizing logistics and business models, which in turn drives innovation in transport and storage solutions. On the other side, the Net Zero Industry Act supports the commercialization and the scale up for projects, which are the focus of the carbon Rhine route. One of the major challenges for any CCS project is navigating the regulatory landscape, and the Net Zero Industry Act simplifies permitting processes and provides those regulatory sandboxes to test innovative solutions, which could benefit some early stage CDR and CCS projects. And on top of that, the Net Zero Industry Act emphasizes skills development. So that ensures that as the ecosystem scales, we have access to a trained workforce capable of supporting the development of the CDR and CCS markets and the broader climate transition. With that, I think I come to the end of my presentation. Next slide, please. So thanks very much for listening. Please feel free to reach out to me directly. My email is on the slides, and I'll be there for questions during the Q&A session later. Thanks very much.
Thank you very much, Dylan. Very much appreciated, very interesting. Next up is Luca, and he's gonna present the project GreenSmith, and we are looking very much forward to that. Welcome, Luca.
Thank you very much. Thank you. So I'm going to present here the GreenSmith project. GreenSmith deal with advancing decarbonization for iron and steel industry. My name is Luca Di Felice, and I'm technology engineer at Feuchter, Italia. Next slide. Just a few words about Feuchter. We are located in Genova, Italy. We are a company of about 300 employees, and our main products are related with iron making industry, in particular coke oven plants, blast furnaces, water treatment, and the dye reduction plants. We are part of SMS Group, which is a company with more than 150 years of history, more than 13,000 employees, and 95 sites globally. Next. This is just a quick overview about our product portfolio. Our main business is on blast furnace and auxiliaries for blast furnaces, with more than 35 projects since the company was born in 2005. Then we also have 11 projects on DRP, so direct reduction plants. We work on coke making under the perspective of the coke batteries, coke gas treatment, and coke machine, and also on water treatment for processed water in the iron and steel industry. Next. Yeah, now let's go a bit more into the topic of what challenges are facing iron and steel in the energy transition that we have to face. We know that 7% of the world CO2 industrial emissions come from iron and steel industry. These account for about 3 gigaton of CO2 per year. And this means that we have to reduce the CO2 footprints if we want to meet the a net zero target. This can be done through different strategies: increased scrap recycle, improved efficiency of iron making, switch the reducing gas, and in particular pointing hydrogen as a key enabler, and also CO2 capture for further use and sequestration. Well, GreenSmith deals with these last 3 points which are mentioned here, and I'm going to show you a bit more how this is done. Next slide. First, just a few words about the project. The title is Gas Processing for Climate Neutral Steel Making, and the consortium is consisting of 6 partners. So next, we have the 2 end users, which are Stegra, which just changed name, but this is H2GS company, which is developing and building the hydrogen green steel plant in north of Sweden. Acciaierie d'Italia, which is owning conventional steel plant in south of Italy. Then we have technology providers, next, which are Polwood, just presented here, and Kisuma, which is a material developer. In particular, they develop sorbents for capturing CO2 in the GreenSmith process. Next. And 2 research organizations, which are Swerim in Sweden and TNO in Netherlands, which is also coordinating the project. Actually, Polwood, we are partner, and TNO is the coordinator. Next slide. What are the goals and the expected impact of GreenSmith? Well, you can read this in the green sentence on the top of this slide. Demonstration of multiple integration routes, advancing the decarbonization potential and maintaining a competitive setup. So 2 keywords here are decarbonization, or at least say advancing decarbonization, and competitiveness of the product that is steel. And this is done through different let's say sub-objectives, which I've listed here. The first one concerns materials development, and as I said before, we are capturing CO2 from streams of steel gas, and we are using solid sorbent for that, and this sorbent needs to be developed in particular from the perspective of optimal shaping, and this is done through this project. And then this is validated with application to the sorption enhanced water gas shift technology. Up to TRL 5 by capturing CO2 and simultaneously producing an increased amount of hydrogen from relevant mixtures of residual steel gas, which come from both blast furnace route or novel natural gas and hydrogen-based DRP, direct reduction plant routes, or a combination of both. Next slide. We also move further in the TRL scale with a TRL 8 rollout of the technology through a basic engineering design package of a pilot of 50 kiloton of CO2 per year from blast furnace gas, which is conceived to be placed at Acciaierie di Taranto site in Italy. And this will facilitate replication, potential and market diffusion. And at the same time, we go through full-scale techno-economics and life cycles analysis for two implementation cases that will be selected during the process. So this will basically serve as a tool for accelerating again the market uptake of the technology that are developed within this project. Next slide, which is also the last slide of the presentation. Just to say, consolidate and wrap up a bit what we have said until now. How does the project contribute to decarbonized and clean energy targets? Well, there are mainly the two routes. The first one is the decarbonization of iron ore-based steelmaking industry by partially replacing coke with hydrogen in the blast furnace route through an efficient integration of the CWEX, sorption acid water gas shift technology. But also on the DRP process, we target an optimized energy recovery and consumption, increased hydrogen content, and lower CO2 emission. This will ultimately bring to an overall reduction of fossil-based fuels consumption, which can impact both DRP and BF technologies. So there is an impact, an unexpected market size of the full 107 megaton per year of crude steel production, which is expected to be in place by 2050. We also have other KPIs which were indicated in the at proposal phase, such as carbon capture rate for the CWEX unit higher than 95%, with a CO2 purity higher than 95%, and reducing carbon footprint to less than 0.4 kilogram of CO2 per ton of hot rolled coil, and price levelized costs for steel below 610 euro per ton and CO2 avoidance costs below 41 euro per ton. And that closes the presentation of GreenSmith. Thank you.
Thank you, Luca. As we are very good on time, may I ask you a question?
Yes.
Yes, because I think it was quite impressive when you showed the map, what wide span of Europe you have from the far north to the very south of Europe. And so I wondered how this transnational collaboration within your consortium added to the value of the project.
Yeah, indeed. There is a lot of complementarities that come in terms of different geographical location of the plants, but also the different technologies which are on the table, and different options which might fit to each of them. So it is really good to have this type of wide interactions and diversity within the project.
Thank you. Thank you very much for these insights. And then the next presenter, yeah, which is Nicole from HyLife. And hi, Nicole.
Hello. Thank you
So
very much.
yeah, so the stage is yours. We can hear you, we can see you, and looking forward to your presentation.
Thank you very much. And thank you for inviting me today to give an overview of our HyLife project. So my name is Nicole Dopffel. I'm working at the Norwegian Research Institute North in Norway, and I'm the coordinator of this project. And I'm very happy to show you a little bit more about our project. So next slide, please. So HyLife, what is this? This is actually a microbiology project, and we are looking at the microbial risks associated with hydrogen underground storage in Europe. And for this, we have gathered a really amazing consortium from different countries, and you can see it here. So we're two partners from Norway, that would be us, North, and the NTNU. We have 3 partners from France, that is the BRGM, INRIA, and Geostock. We have a partner from the Czech Republic, which is the Technical University of Liberec, and we have 1 partner from Germany or Saxony, specifically ESO-Detect. We also have 6 industry partners, which are part of our consortium. That is Lanxess, SLB, BP, OMV, Total Energies, and Coronation. And with this consortium, we are trying to dive now a little bit deeper into the microbial aspects. Next slide, please. So first, I want to introduce you a little bit what is hydrogen underground storage, because this is our main topic. So when we are now going into the future and having an energy system which is based on renewables, the renewables will be mostly coming from wind and solar energy. And of course, there will always be this mismatch when you have a lot of wind, a lot of sun, but actually low demand. So, and there would be the idea that you store this excess energy for later, and then if you have high demand, you can withdraw this energy again. And here, one aspect would be hydrogen storage. Hydrogen is a very good energy carrier, and it's something you can actually store in large quantities. So you would transform the energy to hydrogen, store the hydrogen, and then again, use it for later, either directly or transform it back into electricity. And the best, or I guess only large-scale solutions for hydrogen is underground storage. That means storing the hydrogen not in tanks or in pipelines, but in the subsurface. For example, in salt caverns, which are below ground saline aquifers, or also old depleted gas reservoirs. So this is a technology which has been proposed already for quite some time, and there are field tests and so on. But this is not a technology which is just very straightforward. Next slide, please. So you see the underground or the subsurface storage is really good because, as I said, you can store huge amounts of hydrogen, which is needed if you really want to power, for example, a whole city from this backup energy. And there are a lot of existing storage sites. So nowadays, what we do is we're storing natural gas. I mean, that is also something which is done, for example, in salt caverns, or we have the gas reservoirs. So there's a lot of potential storage sites and all over Europe, which we could even make more. But now the problem is actually for hydrogen specifically, that these underground storage sites, they are not lifeless, sterile environments, but they brim with a lot of diverse life, especially microorganisms. These microorganisms, you can find them everywhere in the subsurface. And actually, microbes, they also love hydrogen. For them, it's exactly a very, very good energy carrier. And most of them actually can just consume hydrogen. And then, of course, that leads to major problems. First of all, of course, you lose your precious hydrogen. You spend energy making it, pumping it underground, and then you have microorganisms feeding on your hydrogen. But then there's also other problems. For example, some of the microbes can produce H2S out of your hydrogen. H2S is very toxic and corrosive. You probably know it. It's this rotten egg smell, so not very nice. Some other microbes can produce methane out of the hydrogen or acetate. Microbes can react with minerals. They can lead to dissolution or precipitation. Microbes also can lead to severe steel corrosion, or also if you have a bloom of microorganisms in your subsurface, you can actually plug your subsurface and your storage site is actually not usable anymore. So this is actually a unique problem just for hydrogen storage and not for other types of energy storage. And this is something we want to look at. Next slide, please. So we actually work now together in our consortium, which consists of 4 different microbiology labs. And what we want to do is we want to answer if this microbial risk is really a big risk for all types of storages and all storages all across Europe. So what we want to do, we sit together, all our 4 labs, we all have experience in these kind of microbiology techniques, and we defined protocols and standards that all the partners actually do the experimental work the same, so that we can compare the results. And with this united strength of lab power, we actually want to investigate as many storage sites as possible. So we get samples from a lot of different possible storage sites of different operators all over Europe, and we investigate the microbial community and the microbial activity in these sites. This we then want at the end to put in a big open database that you can actually try to map out the microbial activity in the subsurface, and we want to see if actually some of the storages are maybe better suited than others. We're also going to test some kind of mitigation because of course you can try to treat the storage sites, and we also want to understand the business risks, which is our cross-cutting aspect in our project. Because if you have to treat sites, for example, you need to add a biocide or you need to clean your gas because you have, for example, H2S. This is additional costs which come into your storage project, and that is a risk for your business case. So, and these microbial risks has not been at all thought of in all the business cases of previous storage, hydrogen storage projects. We also, at the end, when we gathered a lot of information, we want to write then guidelines and recommendations for all the operators and of course also the governments to see where you can actually avoid major failures of storage sites, because it is also quite a risk if you want to have a hydrogen storage sites, which is clean energy, which is of course good, but at the end your storage sites starts to smell like rotten eggs. That is not something we can do. It can't do. You will lose the acceptance very quickly of your neighbors. And so we also want them to use all the methods we have now aligned between the labs to go and also apply it in other storage projects. Next slide, please. So what we really want to have at the end of our project is that we want to really find the key indicators for microbial risks. So what do you actually, if you have a potential storage site, what do you really need to look out for? Maybe we have actually already some key players. We can tell you if you find them, your storage site is probably good or not good. Of course, the standards, the protocols is really important to define a common basis, because only if you do it in a certain way, you can compare your results. And of course, we want to really do this broad scale microbial mapping and evaluation process so that we really can say how big this risk is and what will be then again the business specific risks. And we also want to touch really on the mitigation and management strategies, not into detail because that's, I guess, a whole of our own project, but at least we want to lay the ground to really do some first tests and experiments to see where we should go into the future for that. Next slide, please. So in our project, we're really going from the tiniest living beings in Europe, the microorganisms, and want to look then at the really big scale of all of Europe. So really we want to see where are the most stable hydrogen storage sites. Can we actually tell, okay, this is kind of a formation or which is more suitable, or maybe salt caverns are more suitable now. So these kind of recommendations where we at least can start to make hydrogen storage safer. And then, of course, we want to provide selection criteria. And also, as I said, so maybe we can find really the most favorable sites. Right now, we're in a good position because we have so many potential sites that we really can just choose. Because we don't need so much hydrogen storage in the next 10 years. That will be more on a long-term basis. So right now we really can carefully choose the best ones and then make it as safe and stable as possible until we get even more knowledge to then say, okay, how we treat and mitigate maybe the less favorable ones. And with this, of course, the overall goal is that we have a safe, large-scale and long-term hydrogen underground storage, which is just needed if we want to have energy backup. Next slide, please. So we are very active in HyLife with the dissemination. So you can follow us on LinkedIn or you look at our website. We have YouTube videos on all our protocols we developed, and everything is also accessible online. So if you provide samples, you will also get a button that you sampled for us. So you can follow us live on our achievements and milestones. Next slide, please. So how does this now in perspective with the new Industry Act? As I said, the hydrogen storage is really crucial for the seasonal energy storage. So as you can see also in the graph is that really if you want to store energy not on days, but really on weeks and months and seasons, hydrogen storage is actually the only viable option we have for now. So we need this hydrogen storage to work to support the electrification, because not everything can be electrified directly, or as I said, we need power backup just to make it work. And subsurface hydrogen storage is the most safe and cost-effective form of energy storage. But to make this happen, we need to understand the differences between the sites and what to look out for and how we actually mitigate the problems when they occur. So, and the Industry Act really emphasizes also this large-scale storage, energy storage, which just is needed. Otherwise, we can't decarbonize the industry and the society how we actually envision it to be. Next slide, please. So we really hope that our project supports the overall decarbonization pathway in Europe, just by understanding really the tiniest risks, well, not the tiniest risks, but the risk from the tiniest organisms and how they actually threaten the hydrogen underground storage. With this, we want to improve the TRL and make the seasonal storage safe. And if you have safe storage, that means your hydrogen is stable, you don't get toxic byproducts, you don't run into some kind of infrastructure problems, operational problems, you will build trust and you will have also a better availability of your hydrogen storage. And if you have hydrogen available at all times in your storage, that means your hydrogen is a reliable energy carrier. That means that is good for the industry and the society because you need a reliable energy backup. That's just how it is. We don't want, that our fridge just turns off and then we say, we don't have energy anymore. So it needs to be there. And with hydrogen as a key component, we have also the storage, which is just crucial. And with the Industry Act, this should then also make everything quicker and less complicated to actually achieve the decarbonization we need to achieve. And with this, that would be then my last slide. Thank you very much. As I said, you can follow us on our social media accounts or you can write me. And I will be then also ready for questions in our later session.
Hi, Nicole. Thank you very much. And maybe allow me one question already now, and actually hook up on what you said last year, that you were asking people to follow you on social media and so on. Could you tell us a little bit more why you're putting an emphasis on this and why this is so important for you?
I mean, here it is especially important for us because we rely on the samples from operators. So the operators which give us the samples, they're not part of our consortium. So they just do this, on their own because they're interested and on their own costs. So we need to have a lot of outreach to reach a lot of people and especially the stakeholders, the operators, that they get aware of this problem, that it is a problem at all, and that they can actually helping to solve the problem by contributing, for example, to our project. So this is why we really try to share as much as possible on a variety of different channels to reach also the people who are affected by these problems.
So you made me personally very curious because I would like to get such a button. So, if somebody wants to collect samples, can everybody go out and collect samples, or what's needed to collect samples?
Yeah, it's like everyone who actually has access to a potential storage site, they can get in touch with us and we will send you everything you need. You get a sampling kit, you get the sampling protocol, we have the videos, and then we send you everything. You take the sample, ship it back, and you get this amazing button as a thank you. And of course, you get your data of your storage site back and some interpretation because it is of course also included. But everybody can take part.
It sounds very gamification-like already. I like this, and I have to say, when you were talking, this reminded me a lot to Star Trek and geoengineering and all these topics, because you bridge this gap between biology and technology, which I think is very fascinating and science fiction, like for me at least. Yeah. So thanks for this great insight and inspirational presentation. And we would move to the next project. Thank you, Nicole. So the next project sounds like dessert, but it's a project as well, strawberries. And welcome, Fabian. And I would like to hand the stage over to you to present your project. Thank you.
Yeah, thank you very much. Just a short question. Yes, now I have like access. I guess. Okay, one moment.
Just give Fabian a second so that he can have the control of the presentation.
Okay, there.
It might take a few seconds.
If I'm in, wait.
I see a mouse moving.
Yes, one moment. Okay, it's not working. Otherwise, Anna Maria, just load the slides and then yeah, just continue. Because I can't use the control.
Just take your time. Yeah, we are not in a hurry. We are good in time. So if you take a minute or some seconds, no problem.
Can you check if your keyboard next? the right arrow works? Okay.
Now
Right.
it's working now. Okay,
Perfect.
perfect. Yeah,
So,
perfect, great.
Fabian, the stage and the control is yours.
Thank you very much, Florian. Yeah, so thank you very much for having me here today and for asking us to present strawberries. Yeah, I said strawberries is no dessert. So yeah, it stands for solar thermal agriculture with bifacial collectors for farming synergies. So basically, our main goal is to bring the approach, what we have in photovoltaics already, the agri-photovoltaics approach, what some people of you might heard of, to bring this to the solar thermal world now, because the main challenges of solar thermal heating systems, when you talk about district heating, is also land scarcity, what we have in urban areas, mostly because solar thermal district heating plants are reliant on being as close as possible to district heating grids to reduce the thermal losses. And our goal with strawberries is to catch up with that challenge with the first ever bifacial collector that we developed at the THI. And yeah, therefore we have like a broad consortium all over Europe, and from industry, from research, and also from local stakeholders. So we have on the research side, at one hand, we have us, it's the THI, that's the Institute of New Energy Systems. We are coordinating the project and also responsible for simulation and scientific evaluation. We have the University of Minho, what's in Portugal, that's responsible for developing a absorber coating. I will tell you in one moment more about the collector. And yeah, then also from industry, we are also pretty strong there. We have Nextusan that are experts on vertical agri-photovoltaics, C-Tree Solar, that are also focused on solar thermal systems and energy storages. And we have also support from our Finnish side, where we have also like the biggest stakeholders in solar thermal heating systems, and also from Slovenia, supporters in the manufacturing of the components. And also in strawberries, what's also maybe an interesting approach, we are also working together with a local energy cooperative that are also more and more distributed all over Germany, to bring these principles into society and to show that solar thermal district heating can be a reliant energy source for municipal heating systems. So yeah, then we come to the next. So let's focus on what are we researching on, what innovative approaches do we have, and how strawberry is pushing the boundaries. So yes. Yeah, so strawberries at THI, there was a few years ago, like the thought, okay, how could we make solar thermal collectors more efficient, but also not like to make the production too complex. So we searched for two areas and combined, let's say, the best of both worlds. At one hand, the insulating glass unit production, what's a highly automated manufacturing technology, also widely distributed all over Europe, and also the design principles of flat plate collectors. And let's search for efficiency improvements and also on thinking about, okay, how do we need to adjust the manufacturing process for insulating glass manufacturers to design to produce solar thermal collectors. And this led us to something what we call the insulating glass flat plate collector, so the IGFPC. And what's basically just now you have like kind of like a window. We have like on both sides, you have like a transparent glass, and then you have a solar absorber in the middle that's responsible for collecting the solar energy and heating up the heat fluid. And this technology brings us two key advantages. So on the one hand, we have the decentralized production because, as said, insulating glass unit production is pretty well established. And now with that, we could have the possibility to do licensed manufacturing. So solar thermal manufacturers do not even need to rely on having their own manufacturing capacities. They can give out the license to insulating glass unit producers to manufacture solar thermal collectors. And this brings us then also like to other advantages that come with that, with the decrease of production costs, with a higher scalability because we can produce more where we actually need it. And what also was mentioned in the podium's discussion beforehand, like that we have already EU located supply chain. let's keep it in mind when I talk about Net Zero Industry Act. And the second advantage of this solar thermal collector is its bifaciality, what I already explained to you. So two glass sides. And this brings us two advantages. So overall, first, say like through the production process and everything, we can reach a collector efficiency increase of 10% in comparison to market available flat plate collectors. So we also made a development here. And now with the bifaciality, we have the possibility, it allows us to vertically mount solar collectors, what was not possible so far. And therefore, this brings us to reduced land usage. And now I already told you something about agriculture and something with farming. So what has it to do with it? So now we could think about combining like the agricultural usage of land and also the solar, like the thermal energy usage of land. So what we get is not agri-PV, but we get an agri-solar thermal heating plant, an agri-ST system, where the farmer still can use its field for food production, but also profit from this thermal yield production, what he can sell to district heating grid operators, also get rent for its land, what he offers. So what we aim for with that collector, we can reduce the land requirement to 1/3 of already of conventional solar heating plants. So that's a major benefit, like for asset for urban areas where we have also limited land available, and we don't want to use it all for huge solar parks. So it can increase also the acceptance. We also found out in simulation studies that we've already prepared that we have a similar amount of energy as a normal system, what could be like for example 30 degrees south oriented system. And yeah, therefore we provide a solution for land scarcity and try also to increase the acceptance for solar thermal district heating. So yeah, what are our goals and our expected impact? Yeah, so first of all, it's a goal to successfully demonstrate this concept for agri-solar thermal heating. Also then, when we think about the manufacturing technology, we want to have a rollout and a distributed mass production strategy by 2030. So we are at a point where we know this works. So we want to get this also now out into manufacturing, out to the SMEs, that they can adapt this technology and come up with the solution on the market. And then, yeah, provide a solution for land competition for the farmer, for municipalities that are also in front of a huge challenge on how to decarbonize their district heating grids, for example. So the impact on the energy transition, we have a better land efficient heating system while it gives you the same benefits. We also have the same advantages as agri-photovoltaic, so we increase biodiversity with that also. It will for sure save greenhouse gas emissions, and yeah, we are also planning to open up like a demonstration plan to show that this technology is capable of that. And yeah, it could lead to bigger CO2 saving emissions of 665,000 tons per year if we assume a 10% solar fraction in future heating market. So yeah, and now let's see that in the perspective of the Net Zero Industry Act. So how does it address to be competitive and sustainable manufacturing? What impact does it have on boosting EU production, and to what extent could NZIA support commercialization and scale up? So first of all, with strawberries, we provide a solution for two industries, for an already existing insulating glass unit, insulating glass manufacturing industry. And now we can provide a solution that offers them to profit from a growing solar heat sector. So, and also we provide a solution for the solar heating market that could, that increases the acceptance, and that also like now solar thermal collector producers in Europe gives a chance to explore a new market field. And yeah, therefore the regulatory sandbox was mentioned in the NZIA are a possibility for then maybe also joint ventures between two companies, for example, to explore the adaptability of their manufacturing processes in a maybe more safer environment what we would have now. So, and what's also maybe important, what was also mentioned earlier in the morning, that solar thermal plants can be defined as projects of strategic interest with that technology, for example. So this could also be a benefit for the technology we provide and also for the solar heat sector in general. And yeah, and maybe why is that important? Maybe just at last to get the bigger picture of it. Why? So as said already, heating and cooling is a major part of EU's energy demand, and the share of renewables is pretty low there so far. And therefore, solar thermal manufacturers are already capable of meeting the demand for Europe, and they're also capable of exporting like a huge amount of the production. So, and often if we talk about the solar sector, we often talk about photovoltaics. But what we see here also for when you look on the trade volume, that solar thermal heat, so solar heat, solar district heating, industrial solar heat, it can provide a benefit. It can provide more value for the European market, but therefore we need more policy support. Yeah, and so it can be a complementary part of a European clean tech sector, a European clean tech solution, additionally to electrification of district heating grids. And yeah, let's wrap it up then with the last point. So if we already have a proven technology and now also bringing up a new technology to increase acceptance, to reduce land usage, then why don't we make more out of that? And yeah, that was my presentation. Thank you very much.
Thank you, Fabian. Very interesting. I would have a short question in this regards. It might be rather naive, but I would be interested if this is an aspect as well, maybe, because what you told us is mostly about mitigation at the first step. But is this maybe as well a viable adaptation strategy in regards of shadowing and decreasing, how to say it, the effects of the sun?
Yeah, so with vertical agri-solar systems, we have definitely like a proven increase in biodiversity. That was also shown in agri-photovoltaics, for example. We also have, so we also like prevent ground erosion. Yeah, so the shadowing aspect is not as huge as we might have like highly elevated solar modules or solar collectors. But still, yeah, it can be also seen as a possibility then for sure to increase your revenue for farming also.
Super interesting aspects as well. I think that are going into totally different directions than like urban planning and landscaping and so on. Yeah, this regards. Thank you, Fabian. Very interesting. We are a little bit ahead of our time, 10 minutes more or less. So we would head into the coffee break a little bit early, 10 minutes early. So our coffee break will be not until 30, but until 20 minutes past 2. And we will look forward to see you back then and to dive into 2 more projects. Thank you. Can we stay with the? Can we please stay with the slide before? Thank you. Yeah, so we'll have now two more project presentation of Transmit and WaMTec, and after that we'll head into the Q&A sessions in breakout rooms where you all can ask some questions. And after this, we'll have a short wrap up, and then we come to the closing of the day. Next up is Pedro, and Pedro, please come to the stage. I can see already his video, but not on the stage. Hi, Pedro.
Hello?
Yes, we can hear you. We can see you.
Okay.
So I would hand over to you to present Transmit, your project.
Okay, thank you very much. So I guess we can go to the next slide already. Do I have control over the slide? Okay. So before getting into the details, as I say here, I would like to take you all to the city. So here we have, as you all know, we have New York City as like 8.3 million people. And like many of the other cities in the world, New York City is also becoming bigger. It's getting bigger all the time. It's getting taller, and it's full of these energy-hungry buildings. And there are some expectations regarding these buildings of the future. This is actually why we're here. And so the expectation is for these buildings to be somewhat energy self-sufficient. So we would like them to have the capability to produce most of the energy they consume on site. And this will happen by combining lots of different clean energy sources. And here is where PV or photovoltaics can actually help. But there's a catch. Next slide, please. So regarding PV, there's a problem because there's not a lot of space in cities for PV deployment. And as we see here, an idea of how we can solve this problem in, let's say, New York, we could actually wipe out Central Park. We would install a central PV park and problem solved. So, but since this is not going to happen, we have to try to fit our PV into the buildings. But if we think of buildings rooftops, they don't really offer a nice area for deployment of PV because you have these incredibly tall buildings, but the building implantation area is very small. So there's not enough room. There's not enough space. However, in the next slide, we can see there's lots of space on the buildings windows, and this is where Transmit, our project, comes to play. The project is called Semi-Transparent Microstripe Thin Film Photovoltaics for Energy Harvesting Windows, and I think we can, by these two pictures, kind of understand the logo and the name of the project. So basically, we're trying to develop semi-transparent photovoltaic devices on glass so they could be used as photovoltaic or solar windows, as I like to say. So imagine all these buildings on the right, they're covered in glass. So the area of deployment, the area for deployment of PV increases massively if we can do this on buildings windows. So, and here we can start thinking about actually generating lots of energy on site. So next slide, please. So I will start with presenting the consortium before going into the project details. So we have 6 partners from 5 countries. So we have us here at Annul in Portugal. We are coordinating the project, and we will explore one type of material, which is a photovoltaic material, which is CIGS. So we're going to do CIGS-based semi-transparent PVs. Then we have our partners in Italy, part of INSTM. We have the University of Genova, and we have University of Rome Tor Vergata, and they're they're going to explore perovskite materials for the semi-transparent PV. Then we have our partners in Cyprus. They will both the CIGS and the perovskite partners will send devices to Cyprus, and they'll do the device validation in relevant environments. Then we have also partners in Turkey, in Ankara. We have both METU, the Middle East Technical University, who will work on building energy performance assessment, and also the partners of Otugunam. They will do the socioeconomic impact studies. And finally, we have also partners from Bézoltán in Hungary that will do life cycle assessment and life cycling cost of our technology. Next slide. So what's our research focus and the key innovations? So as I said, we are developing a STPV, so a semi-transparent PV device, which is based on copper, indium, gallium diselenides, or CIGS solar cells, and with a different route, also perovskite materials. And so what we're going to do here, we are going to make very thin and then so-called microstriped solar cells, and they are separated by a transparent gap. So basically, it's like the sunlight will hit the solar cell or the microlines. It will be absorbed, and in the transparent gap, light passes through, and we have light inside our building. So imagine here on the left, imagine that you're in this office, and then this window has a semi-transparent PV. But the thing is that from afar, you cannot really see it. You need to come close to it to really see that there's something on the glass. And this is one of the probably the main innovation is the design. We are trying to make these solar cell lines indistinguishable to the human eye, because at a certain distance, let's say a meter, your eyes can no longer resolve the features. Next slide. So and here we can actually play with the transparency and therefore the efficiency of the device. Like, we can't adjust the micro solar cells width and pitch, and by that we can control the amount of light that passes through our device, and then we can actually tailor the device to specific applications. And we're also pushing the state of the art by we're trying to deliver aesthetically pleasing and color neutral devices. And this is very important, because if your device is very view impeding, if it's ugly, the end user, the architects, the builders, they will not want this on their buildings. This needs to be pretty, and this also needs to be efficient. So as you can see here, I probably have a real demonstration. When you have your device close to your eye, so at a small distance, you can clearly see the features, but as you at a distance, you can no longer see what it is. You can actually see the background, so you have the desired effect. Next slide. So our goals, we intend with this project to fabricate and validate these STPV devices at TRL5. So we're going to use, in one hand, we're going to build CIGS-based devices, and on the other hand, perovskite-based. And the CIGS will be, these mini modules will be 5 by 5 centimeters, and the perovskites will be 10 by 10 centimeters. And we are aiming at a 8% efficiency and a 50% device transparency. Another thing that's our goal is to assess the environmental impact of our technology, and also to determine its economic viability. We also intend to analyze the building energy use and the thermal comfort, and also the social acceptance of this technology. Next slide. So for the expected impact. So at TRL5, we expect to have or to win the stakeholders' confidence, the investors and partners, because and we are trying to present this appealing solution that has like this seamlessly integration. So, and we are prioritizing the end user comfort and well-being. So we want to attract attention to the technology. Also, we expect to do some de-risking. So the technical risks can be reduced at this stage as the technology moves towards higher maturity and market readiness. At a higher TRL level, TRL 5, then this can be actually applied into buildings, and can massively increase the PV deployment in cities, and therefore enabling the on-site electricity production as we are expected in net zero buildings. Next slide. So our project in the perspective of the Net Zero Industry Act. So I think it's important to know that worldwide, the building sector accounts for like 36% of the energy consumption and around 40% of the energy-related CO2 emissions. So this semi-transparent technology would enhance the building's capability to generate this clean energy and then reduce the dependence on the fossil fuel energy sources. On the other hand, this project could also promote the development of European-based semi-transparent PV technology, and then to ensure that some EU-produced solution could remain globally competitive. And next slide. So another important feature, at least with the CIGS approach, the manufacturing capability for CIGS solar cells or opaque CIGS solar cells is already implemented in Europe. So our technology differs from the opaque solar cells just in one fabrication step. So there's already some important steps or industry already in place due to the CIGS solar cells. And as I've learned in today's sessions, I realized that the Net Zero Industry Act is not does not intend or doesn't have the main focus on transfer from lab to market, but I think there's many ideas that are still in the lab, and maybe some further help on this part of lab to market could actually accelerate the clean energy commercialization. And the next slide, I guess it's just context. Thank you very much for your attention, and I'll be glad to answer some questions in the breakout sessions.
Thank you, Pedro. Maybe one question I would have, because you said from lab to market, and I think when you're looking at your project, it's a two-sided, or there are two major topics, I guess, and one is a technical solution that you need to build, so it's functioning on this level. The other one is a very, market-orientated and social problem, because as you said, you need to address people, you need people to want to have this solution and to get into buildings and so on. So how do you address these different topics, especially the second one, apart from the technical solution?
Well, so our partners are trying to understand first how the general public would see this, but we realize that the general public would probably like this solution, and the problem is not there. The problem is with the need owner, or with the let's say builders, architects. These are the groups that will actually decide if they would like to, if they want to have such a technology in their projects, because it's not just such a technology. It's like this will be a building block and has a certain appearance and has a certain effect. It affects how the light gets transmitted into the building. So part of our project is to understand how these deciders will see it, so that we can actually, because we have on the fabrication side, we have the possibility to change things, to adapt the device transparency to a certain need. So we need to understand these needs. We need to understand what what is acceptable and what is not acceptable. Probably most on the, as I said, on the builder side, and the architects, the people that actually come up with the buildings. So that's an important part of the project as well.
Okay, thanks. That was very interesting insight, and shows how multidimensional these projects are, and what you need to take into account to move such a project forward and to make it from lab to market. So thanks, Pedro.
Thank you.
Let's move to the next project, which is WaMTec, and I would like to ask Marc on the stage.
Yeah, thank you.
There he is.
I hope you can hear me.
We can hear you live and in color. The stage is yours.
Thank you. Thank you very much. So I'd like to present the project WaMTec to you. Next slide, please. WaMTec stands for From Wafer to Module, Cost-Effective, High-Efficiency Silicon Technologies, and it focuses on photovoltaics, as most of you probably have guessed from the name now. And we're covering a very large part of the value chain, from silicon wafer via the solar cell to solar modules. Next slide, please. And we're doing that with the partners that you can see here on this list, and also with the geographical location on the right-hand side of the map. I'd like to present the partners from south to north. Looking at the Turkish partners, we also are collaborating with Ottobünan, just like Pedro in his project that you saw before, but on different aspects, also on the silicon solar cell technology and also on the module testing, which you will see later. And the module fabrication work and research is going on at the Turkish partner Smart Solar. That is an industrial PV module manufacturer that you find in Turkey. From Germany, it's our institute, Fraunhofer ISE. We are performing research and development in the field of solar, hydrogen, and let's say, in general, the implementation of renewable electricity into the grid, and how to produce, how to distribute this. And in Germany, additionally, we have the company Schmid, that is a manufacturer of production tools for solar cells, but also for other parts of the value chain, also for modules, for example. And from Ireland, we're collaborating with the company Nines Photovoltaics, that also is a producer of production tools for solar cells. And the furthest north, we have the Norwegian partner Norsun, that is a manufacturer of Tucholsky grown silicon wafers that are used as base material for the production of solar cells. And as you see on the right-hand side, it's quite well distributed over Europe with all these partners. Please go to the next slide. So in our project, where, as I said, we're covering the full value chain. We're starting with the silicon wafers, where we're working on high-quality, large P-type silicon wafers that are grown at lowered cost. And on the right-hand top side, you can see an image of the crystal pullers at the Norwegian Norsun site, where Tucholsky grown silicon ingots are grown out of the molten silicon, and they are single crystals. And these wafers are then turned by the partners, where also our institute, Fraunhofer ISE, is playing a big part, into solar cells. And we're working on high efficiency, so-called top core type solar cells. They are based on these P-type wafers. We try in this project to increase the efficiency of the solar cells up to 25.5%, and use these cells to implement them into solar modules. And not only, let's say, these novel solar cells are implemented, but also the light management itself in the solar module is worked on and being improved, having a better transmittance and better rear efficiency of bifacial solar modules. And we will prove the technology that is developed within WaMTec by outdoor tests in the end. And we'll do that in Turkey and also in Germany at 2 different sites. That we have different insulations and also different climate conditions that we see if our new developments really work under different conditions. And in the end, we want to show that our work really is a real life, let's say, changer and provides a 10% lower cost for the solar cell production. On the right-hand side, below the crystallization furnaces and the pullers, you can see in the middle a glimpse of the solar cell research lab at Fraunhofer ISE, where we have 2 high temperature furnaces on left and right, and also automation in front. And on the bottom, you see an image of the outdoor test facility near our institute in Germany. Next slide, please. So I'd like to show you 2 examples for the key innovations we're working on in the project in collaboration between different project partners. The first example is shown on the right-hand side as an image. It's a tool manufactured by Nines Photovoltaics, the Irish company that we're collaborating with, and it's a tool that is using global warming potential free gas, fluorine, that is used to etch silicon. And so it's used for a certain step in the solar cell production. And it's a process that uses within the etching process itself, since it is a dry etching process, it doesn't use any water. But for the waste gas treatment, which you also would need to apply, we need some water. But in total, we have, compared to the state-of-the-art technology, an ultra-low water-consuming process that we're working on. So we have a process that is really environmentally very friendly, also very good for the climate impact of the solar cell production. And additionally, it's also from the cost perspective very interesting because it can process solar cells quite quickly on a very small footprint. Thus, we have, let's say, a small tool with high throughput, also very capable for industrial production. Next slide, please. Second key innovation focuses on the plating of copper contacts instead of screen printing of silver contacts for the solar cells. And this is becoming even more and more important if you look at the right-hand side and the graph that is presented there, because it shows the percentage of the global silver supply to the PV industry. And you see on the x-axis different years in the past, where you could see a roughly steady increase of the silver consumption of the PV industry in the last years. And so in that paper, there were predictions starting in the year 2020. And so different, let's say, ways how you could think of the future of PV production. But in both cases, let's say, it's a high and a low projection, let's say, image. And in both cases, you see an increase. This is also very meaningful because we're expecting also increasing solar cell production, still increasing solar cell production also for the next years. And I just checked last year's number, and I added the big black box with the number, and it's about 19% of the consumption of the total silver supply last year that was absorbed into the PV industry. And So there's good reasons to be expecting an even higher number for this year. So that's a very good reason that to let's say shift from silver to something else like copper, which is a lot more easily accessible and also at lower cost. Please go to the next slide. So looking at our goals and expected impacts. So with the results achieved in WaMTec, we're expecting to get lower costs and also increased efficiency of solar PV. And with that, we think we can allow an even stronger distribution of the PV technology into the society in Europe, but also globally. We will allow the partners of the project to increase their participation in the PV market, because then they have new technology in hand, which can be used to have a better offer than the competitors. And in total, because of the lower cost and increased efficiency, we can foster also low carbon, low cost electricity in general. On the bottom, you see two images. On the left, it's a PV installation as an example on the rooftop with an east and west oriented module configuration. That's one way, let's say, to use the results, the technical results of the project. And on the right-hand bottom side, there is an example of the facade installation. So like it's an alternative to what Pedro has shown. The modules, they are not transparent, but they are colored. So you can see at the facade these green rectangular shaped elements, and they hold solar cells inside. And this coloring is also a development out of a different project from our institute. It's called Morpho Color technology, and it allows the different colors of solar modules without sacrificing a lot of the efficiency of the solar module. So we are below 10% of sacrificing of the efficiency here in this case. Next slide, please. So concerning the question, how will this project contribute to the clean energy transition in real-world applications? I also can add that the innovations that we want to achieve in the project, they are worked on in such a way that they will be mass production compatible and that they can then be transferred to industry very quickly. On the left top, you see an image of a wet chemical inline high throughput solar cell production tool of the company Schmid, also a partner of our project, that will then also hold innovations of the project. And additionally, we will show that the applicability of the novel technologies will really work in outdoor tests, as I said, in 2 climate zones, in Turkey and also in Germany. On the bottom, you see 2 images of the 2 sites in Turkey and Germany. Next slide, please. So now, looking at the perspective of the Net Zero Industry Act and the interaction of our project with that. And we can state that WaMTec's innovations will really help lowering the cost of PV-generated electricity, as I said before. And our goal in the project is the decrease of the cell production cost by 10%. And in the end, the cost for electricity, which typically is stated as levelized cost of PV electricity, will be lowered by about 4%. I said also that before that the industrial production will be more viable, applying the innovations we're working on in our project. And what I'd like to emphasize, and maybe that points out also to what was said by Tristan this morning, by Michele Pori, that we really need a very strong support by the Net Zero Industry Act implementation in all European Union member states in order really to make the PV industry regrow and re-ramp up within the full value chain, because currently we only have, say, a rather leftover of former Europe's PV industry. A very nice example is Tresun in Italy. Very nice to see, but it's very hard to compete for the currently existing PV industry to compete with the ultra cheap prices of Chinese PV modules in the European Union currently. And maybe next slide to emphasize on the situation that we are at. Please go to the next slide. Thank you. Here you can see the PV module production percentage year on year in the last years up to last year. And in blue, you can see the share of the European industry of the global production of PV modules. And let's say up to the year 2009, we had a significant share of the production that was taking place in Europe. And after that, year on year, the percentage was shrinking up to something which is almost invisible on the right-hand side of the graph, with the blue bar being very small. So this is the situation where we are at, but still we want to build an energy system that has photovoltaics as a major pillar. And so currently we are strongly dependent on Chinese supply. And I understood that the Net Zero Industry Act tries to, say, diversify the supply and also get industry back running in Europe. But currently we are not there. We need really strong support from European Union with the regulations to be put in place that also private money goes into that sector. So, thank you very much.
Thank you, Marc. I think that's very interesting, and as well think that your perspective right at the end, mentioning that you need support is a quite interesting emphasis, and was a driving idea of our conference topic as well, and how to address things. So let me ask you, what would this be concrete for you? What measurements would you imagine that should happen out there that would help you to ramp up?
So currently, companies that are from Europe mainly are looking into the US if they are thinking about building new factories, because the financial situation there to build a factory with, let's say, a good framing by the government and also a somewhat protected market makes a perspective that is very viable. And let's say currently in Europe, we're lacking of both. We don't have a protected market. We have super low prices of Chinese modules here. And we're also lacking of really implementation of the Net Zero Industry Act currently. Of course, we're hoping for a quick implementation, but it's not there yet. And if we have that both, let's say, in place, or at least one with such a power that we really can have a frame that works, this is what we need. And currently we still know how to do everything. We still have players that are on the market, but the longer we're waiting, the more difficult it will be to catch up with China.
And you mentioned that you can lower the prices by 10% approximately. Yeah. Do you know what the gap is that we would need to close to have the same prices?
So my colleague actually from Fraunhofer ISE has worked out a study that was published one and a half years ago, let's say, looking at would it be in principle be possible to build up the European manufacturing infrastructure again, and would it be possible to achieve the prices or the cost structure, more talking about cost structure in China. And we saw that once you are at a certain level of size of your fabrication site, it's possible to compete again. So, and because we're not really dependent on huge labor costs anymore, because the optimization rate is very high. So it's not really an issue, let's say, of the labor cost anymore. despite we would need a lot of people working in that industry. But so this is not really an issue anymore. So it's really about regulation being put in place quickly, because as I said, currently we have very good technology in place. For example, the current standard solar cell technology, it's called TOPCon, which is now being produced in China, or let's say being the largest quantity of all kinds of solar cells. That originally was developed at our institute, and now it's produced in China. So because we don't have the setup here in Europe to really have a healthy industry. Yeah, so it's a pity. Yeah, but currently we still know how to do it, and we know also how to do the next step and the next step after that, technology-wise. But we need the frame from the politics. Otherwise, it doesn't work.
So we are right at the core with our discussions when I listen to you. Yeah. Thanks for your input. And thanks for your project presentation. We will now move on to the Q&A sessions, where you can ask your questions, where all our presenters will be present. Therefore, you'll get a small pop-up on your screen, and you can then jump right into each room. There are 2 rooms. You can see the topics. So this is CO2RR, GreenSmith, and HyLife in room 1, and room 2, it's Transmit, Strawberries, and WaMTec. Yes, you'll get the pop-up, you join the room. If it does not work, please write into the chat and our team and let our team know in which room you would like to be, and they will push you into the room. Happy discussions and a lot of questions and hopefully answers, and see you back after the Q&A session. Okay. Hi, Isabel.
Hello.
You're back from the breakout sessions.
We are back. We had a very good discussion. We could have needed some more minutes, but that's how it is when you are having fun discussing.
That's good. There's never enough time for that. It's like holidays.
Yes,
yeah,
exactly.
They're always too short.
Yep.
So let's hear from you guys how the breakout sessions were, how the Q&A was, what were the topics discussed. Maybe even if room 2, let's go with ladies first, and I would hand the stage to Isabel to give us a short wrap up and let us know what has been discussed and what the major topics were.
Yes, thank you. Thank you for giving me the floor first. It was quite an interesting discussion on the solar technologies, and quite a challenge for me as well, as I learned a lot. It was questions were dedicated to the efficiency and the, let's say, the put in place the technologies, especially the new technologies like thin films, the windows, the projects. We heard the information about it. Concerns about the competitiveness with, for instance, technology coming from other countries. And in a way, part of the discussion was based on that, how to promote Europe's competitiveness compared, for instance, to China. That is something that actually should be addressed. And we also looked into the other side of acceptance, let's put this way, of these new technologies, the impact that, for instance, in terms of Windows that it has, and the need for the different stakeholders to participate in this receiving the technology and seeing the advantage of it. And so probably awareness is the word that we should use to be able to transmit the advantages of these new technologies to be put in place. And basically was this. I think I don't forget anything, but thank you. You're muted, Florian. We can't hear you.
Right. Sorry, Isabel. Thanks for your wrap up and for pointing out. Yeah. I would hand over to Age and see what has been discussed in his breakout room and Q&A session.
Yeah, thank you. We had many good discussions, and I would start with the last question we had, and that is whether we should use this captured CO2 for producing saleable products, or if you should store it. And that's a really interesting discussion. And we will probably have to do both. First of all, there is a market for CO2. There's a demand for CO2, and when we start building large-scale CCUS plants, we can utilize the CO2 to create products that we can sell. But the volumes of emitted CO2 around Europe and around the globe is so large that we will quite easily fill up the markets and meet the demand for CO2. So we will need both. We will need to do utilization of CO2 and also to store CO2. We also touched upon the cost of transporting CO2 and also hydrogen. And for a long time, it has believed that the cost of capturing CO2 has been the biggest cost item in the value chain. But we learned that transporting the CO2 is also quite costly. And it also depends on distance. But learning that transport cost is considerable, it is also very important to do the logistics planning. Could you cluster emitters and let them share on the joint infrastructure for transport and storage? And we also touched upon storage of hydrogen and CO2. And for storing CO2, we have for a long time learned that the public can be skeptic. They do not like to have CO2 in the backyard. And from the HyLife project, where they are focusing on storage of hydrogen, we learned that there can be challenges, social challenges when it comes to hydrogen, of course, but that should be possible to handle. And furthermore, you can all, if you are planning building new hydrogen production facilities, you could locate them close to storage sites, so that reduces transport costs. But hydrogen will be a valuable product, more valuable than CO2 maybe, and that might also affect social acceptance for storage. So we touched upon several interesting topics that we could continue to discuss for a long time. But in the end, I would also like to bring up the relevance to the Net Zero Industrial Act. And we learned from the discussion that permitting is or can be a bottleneck. So we were happy to see this morning that this was one thing that was addressed in the presentation from the European Commission. But what we can learn from this is that it's not necessarily the technology that is the most difficult part. It can be other things like the permitting. But in general, we believe that the technology is developing quite well. But one of the challenges is to go from the very good research we see in the CTP project to develop the technology large scale. So I think I ended by that. I hope I didn't miss too much of the important things we discussed.
Thanks, Age. I as well wanted to ask, was this the net zero effect and impact well part of your discussion?
Well, not really. I mean, it was embedded in the discussion, yes, but we didn't really specifically address the questions in terms of the act, but because those were presented with the projects. But anyway, we were, and the technologies that we were talking about in a way had to do with CO2 reduction, and the solutions are there, so we're more related also to cost and new technologies, and that's the way we looked at it. Let's put it this way.
Okay, thanks. And maybe another closing question to the both of you, because we are discussing all these topics in the backdrop of the CET partnership. So was the topic of the CET partnership and what we are doing and how we are contributing to this discussion part of your Q&A sessions and the discussions?
Yes. The questions I addressed, let's put this way, the audience was technology specific oriented questions, I would say. So we had obviously experts on the technology, and they wanted to discuss the new features and also the fact that the solutions are there, and so why they are not more widely used. And we addressed some of the things like, at least part of my curiosity was on regulation or policy, but in terms of CTP, I also in terms of timing, because CTP has a certain duration and the time for the projects to have an impact, and that it proved to be a difficult question, let's put this way, to be answered, where, I mean, some of the solutions are there, and of course they could be used, they are not used, and according to the discussion and the answers I had from the projects is that it needs more engagement of different sectors to be accepted and put in place, let's put it this way. I hope I got it right, and everything we've done. So I didn't have the time to go into, for instance, discussing the how CTP could help to increase this awareness and to put forward the advantages of using these new systems, and also in terms of policy recommendations. We didn't have time for that. So I think there is room for further discussion in the future.
Thank you, Isabel. Age.
Yeah, same here. The discussion was mostly on technology, and that makes sense because the CTP projects that we had on stage, they are technological projects. But for the future, maybe we within CTP can try to do a better job in joining the technological people with decision makers and politicians, because I believe that the projects in our portfolio are developing a lot of knowledge that could be useful also for decision makers.
Thanks, Argen. I think this is already good last words, more or less, yeah, because this shows what we intended to do with the conference as well, yeah, to take something from a policy level and to make it concrete. And what we saw in the discussion, and that's what I'm taking from what I hear from you now, is that people are very, how to say, solving orientated, yeah. They want to discuss the technologies, but are very aware of what is behind it. And I think this is a wonderful day, and what we were able to show today, that exactly this circle and this line you just outlined, Auge, is materializing in front of our eyes in the ways that they carried out, and how concrete these discussions are, but as well shows what a viable part the CETPartnership can play in this process of moving things forward and connecting exactly policies with action on the ground and with things happening. So thanks for your feedback and your input and moderating the two sessions. We are very thankful for that. And by that, we would close now the wrap up and plenary session and move to the last point. This is giving an outlook for tomorrow. I would need the presentation a little bit bigger. My eyes are old and not that good anymore. Thank you very much. So tomorrow we'll start at 9 o'clock in the morning. We'll have a short welcome and introduction. Then we will move on and we will discuss the Net Zero Industry Act and the regulatory sandboxes. So this will be an input and as well the living labs and sandboxing, so that we will get input on this. And then after this, we will have parallel interactive sessions of 2 rounds where we'll discuss these tools, and there will be a lot of room to get more practical as we just did now. And then at the end of the day, we will have a nice wrap up and outlook into the future, what's going to be upcoming and what's beyond the Net Zero Industry Act, so to say. And in the afternoon, we'll have a short information on the joint call 2024 with a Q&A session. So this is going to be tomorrow. We hope that a lot of you are coming back tomorrow. Please let other people know if you liked it. I think tomorrow will be exciting as well. And what is left for me is to say thank you for being here, for taking the time, and for being part of this discussion and this journey to a positive future. Thank you very much. And see you soon, latest in the next conference. Thank you. Bye.